The use of chlorofluorocarbon, or CFC, has been long recognized as a global environmental problem. CFCs have been a primary component in refrigerants used in automotive air conditioning systems. Hydrofluorocarbon, or HFCs, which are considered to be environmentally safe, are being used to replace CFCs. Therefore, R12 air conditioning systems traditionally installed in Freightliner trucks are being replaced with the new environmentally safe R134A systems. The change to refrigerant R134A has necessitated a number of changes to the air conditioning system and the service and troubleshooting procedures for the new system. The first part of this program will explain the major component changes. The first noticeable change is the absence of service ports on the compressor. The lines are larger at the compressor, 1-inch tube O lines instead of the smaller number 8 and number 10 lines. A tag on the compressor identifies it as an R134A compressor. The service ports have been moved to where the AC lines pass through the bulkhead on conventionals and the right wheel well area of COEs. The service ports are larger and feature metric quick disconnect fittings. The condenser looks the same, but is designed to be more efficient at removing heat from the refrigerant. The system hoses are the same Parker-Hannifin P80 hoses that Freightliner has used since 1988. The hose features a nylon barrier core to keep refrigerant in and moisture out. The neoprene O-rings are the same as those used with the R12 system. The O-ring color changed to red in 1992. The receiver dryer is longer and contains more desiccant, XH9. The R12 system used XH5 desiccant. XH9 will work with either system. However, XH5 will damage an R134A system. The moisture indicator is the same, and while there is a sight glass, it is not useful in the system. The pressure switches are unchanged, as is the evaporator core. The thermostatic expansion valve is the same, with one minor change. It uses R134A gas inside the sense tube. Freightliner has established service and troubleshooting procedures for the R134A air conditioning system. These procedures are designed to assist the technician in a quick and efficient diagnosis and servicing of the system. Although system configurations differ depending on the vehicle, the standard preliminary checks found in Section 83.04 of the FLB-FLD Service Manual apply to all vehicles with R134A systems. In this video, we'll concentrate on the FLD model. For the medium conventional and medium truck, consult the section of the service manuals for those vehicles which contain information about the R134A system. The process, which we'll highlight in this program, is fully detailed in the service manual and begins from the moment the vehicle arrives. Find out as much as you can about the problem from the person who uses the AC system, the driver. After getting a basic idea of the difficulty the driver is experiencing, start the engine. Set the engine speed at 1500 RPM and build up full air brake system pressure. Close the doors and windows and turn on the air conditioning, setting the controls at maximum cooling with the blower on high. If the vehicle is equipped with an auxiliary AC system, turn it on full also. Place a thermometer inside the center dash outlet. While this is in place, you'll continue with the remaining performance checks, leaving the thermometer in the dash for at least 10 minutes. Check for proper airflow from each vent. If the airflow is low, check for debris that might be blocking the air recirc inlet. If that's not the problem, see if a duct has come loose or has collapsed. Then set the controls to AC. Check again for proper airflow from each vent. If the airflow is still low, check the outside air inlet for leaves and debris. Check the blower motor to be certain it's putting out airflow on all its speeds. Blower motor troubleshooting, removal, and installation instructions are contained in the FLB-FLD Service Manual, Section 83.04. Visually check the AC belt to be certain it isn't slipping. And make certain the AC compressor clutch is engaging, while listening for unusual noises from the compressor. With a Horton on-off fan, the AC compressor clutch won't engage until the vehicle air system pressure is above 65 psi. Carefully check all the AC system lines, starting with the discharge line at the compressor. It should feel hot. The suction line should feel cold. If the lines are warm, the compressor could be faulty, or the R134A charge in the system could be extremely low. Feel the inlet and outlet at the condenser. There should be a noticeable temperature difference, with the inlet being warmer than the outlet. The line from the condenser to the receiver dryer should feel warm. A cool spot indicates a restriction. If the line is hot, the condenser isn't working correctly. The inlet and outlet of the receiver dryer should be the same temperature. If not, the filter could be plugged. The line from the receiver dryer to the evaporator should feel warm. An icy spot indicates a restriction. Finally, the line from the evaporator to the compressor should feel cold. A warm line could indicate a bad expansion valve. An icy line indicates that the expansion valve could be stuck open or that the system has been overcharged with refrigerant. If the evaporator freezes over, a thermostatic switch capillary tube may be bent, kinked, or mislocated, conditions which can also lead to other symptoms of other AC problems. Unlike an R12 system, R134A systems do not leave an oily residue when they leak. Any moisture indicator color other than blue means that there is excess moisture in the system. Check the water regulator valve. If it isn't closing all the way, heat will enter the cab, giving the impression that the AC isn't working. Check the engine temperature. If the engine is running hot, the AC system will not be as efficient because the condenser will be picking up heat from the radiator. Compare the center dash temperature readings to those found on the AC troubleshooting chart in the specification section of the service manual. If the reading is too high, the system isn't operating correctly. Refer to the troubleshooting chart in the service manual for possible causes. Shut down the engine. After the engine is shut down, feel across the surface of the condenser and the tube ends. Any cool spots indicate a damaged tube. Visually check the AC pulley to see if the belt is slipping or worn. If you suspect an electrical problem, there are a couple of additional checks to perform in order to track down the cause of a problem with the AC system. If you discovered earlier that the AC compressor clutch wasn't engaging, remembering that the clutch won't engage until the vehicle's air system pressure is above 65 psi, check the voltage drop of the compressor clutch ground circuit. First, turn the key on with the engine off. With the blower motor on high and the AC control level at maximum AC, disconnect the AC clutch power lead at the connector at the compressor. Attach the positive probe of a voltmeter to the power lead. Touch the voltmeter negative probe to a good ground. Then touch the voltmeter negative probe to the compressor case as close to the clutch as possible. Compare the readings. They should not be more than 0.25 volts different. If they are, the compressor isn't properly grounded to the engine. Using an ohm meter, check for continuity through the coil. If the coil is open, replace the clutch. If no voltage is reaching the compressor clutch, turn off the key and check the thermostatic switch. This procedure is contained in the service manual. If the thermometer you inserted into the center dash outlet indicated a high temperature reading, check the refrigerant pressure in the system by connecting a UL-approved R134A recovery charging station to the service ports. The station features gauges for measuring pressure on the low and high sides of the system. Review the safety precautions contained in the service manual. Failure to review these safety precautions and to be aware of the dangers involved when working with refrigerant could result in serious personal injury. Safety glasses and cotton gloves must always be worn when working with R134A. Begin the procedure by making sure both manifold valves on the R134A station are closed. Pull back the collar and connect the manifold hoses to the system's Quick Connect service ports. Connect the red hose to the high-pressure service port and the blue hose to the low-pressure service port. Turn the knobs to open the Schrader valves. On conventionals, the service valves are near where the lines pass through the bulkhead into the cab. On COEs, they are located in the right wheel well area on the lines for the auxiliary AC unit. After connecting the recovery charging station, start the engine. With the engine running at 1500 RPM, the on-off fan turned on, the system on max AC, and the doors open, normal low pressure should be between 20 and 35 psi on a COE and 15 and 25 psi on a conventional. Normal high pressure should be between 175 and 225 psi on a COE and between 100 and 150 psi on a conventional. Check the service manual for gauge readings by vehicle type. Low gauge readings indicate the system is low on refrigerant. An extremely low charge will be indicated by lower gauge readings. Some gauge readings, examples of which we'll see in a moment, may indicate the necessity to purge or flush the system. If a sample of oil from the compressor shows it has been contaminated by excess water, oil, or dirt, the system must be purged or flushed. Purging involves the use of a dry, inert gas, such as nitrogen, to blow out wet air, rust, or loose dirt from the plumbing. Do not use shop air. Flushing, which is reserved for extremely contaminated systems, involves the use of liquid R134A under pressure. R134A is pushed through the system, and filters are used to remove contaminants. The R134A is returned to a refrigerant recovery station in a closed loop. No other substance but R134A can be used for this process. New flush materials are under development. Check the service manual for detailed precautions and step-by-step procedures for purging and flushing the system. If there is some air and moisture in the system, pressure readings will be normal even though the air conditioning is providing insufficient cooling. Any leaks will have to be repaired. If there is excessive air and moisture in the system, the suction pressure will be high at first, then drop to a lower range or indicate a vacuum as the system runs. The discharge pressure will run high. Any leaks will have to be repaired, and the system will require purging or flushing. If the condenser or radiator air passages are clogged, or if the system has been overcharged with refrigerant, both suction and discharge pressures will be high. If the air passages are clogged, the condenser and radiator fins must be cleaned. If the system is overcharged, refrigerant must be recovered and the system must be recharged with the correct charge. If there is a restriction between the compressor and the expansion valve, suction pressure will be low, and discharge pressure will read normal to high, unless the restriction is between the compressor and the receiver dryer, in which case the discharge pressure will be extremely high. Damaged parts must be identified and replaced, and the system must be purged or flushed. If the expansion valve is restricting the flow of refrigerant, is stuck closed, or contains a malfunctioning temperature sensor, the pressure on both the discharge and suction sides of the system will be low, although normal pressures can be restored when a hot wet rag is applied to the expansion valve. In this case, the expansion valve must be replaced. Also, if there are any contaminants present in the thermostatic expansion valve, the system must be purged or flushed. If the expansion valve is stuck open, causing flooding of the evaporator coil, the suction pressure will be high, while discharge pressure will be low. The expansion valve must be replaced. If the belts are loose or worn, if the compressor clutch isn't working, if there's an internal leak in the compressor, or if the pressure switches are not working, pressure on the suction side will be high and pressure on the discharge side will be low. Belts, engine drive pulley, compressor, clutch, or pressure switches must be replaced as needed. Whenever pressure is low on both sides of the system, or pressure is normal but the AC isn't putting out sufficient cooling, or the gauge readings indicate the presence of air and moisture in the system, you must check for leaks along all lines and fittings. Several methods are available, but Freightliner recommends use of an electronic detector for fluorine, which produces an audible warning when a leak has been discovered. Pressurizing the system with dry nitrogen helps to find slow leaks. Other methods may be dangerous to personnel or damaging to the system. Never use shop air because R134A under pressure with oxygen is flammable. In this case, the technician has discovered a leak at one of the connections at the receiver dryer. Before the leak can be repaired, the R134A in the system must be discharged into a recovery charging station. An R12 recovery station cannot be used to recover R134A. R134A could damage an R12 recovery machine. Remember, use only a UL-approved R134A machine. Follow the manufacturer's instructions for discharging the system. The cause of the leak was a torn O-ring, which the technician replaces. Use mineral oil to lubricate the new O-ring. PAG oil, which we'll talk about in more detail in just a moment, would attract moisture and cause the fitting to corrode. Whenever the charge is dropped from the system, the receiver dryer should be replaced. While the charge is dropped, check the oil level in the compressor. Instructions for a full oil change are contained in the service manual. As mentioned, the R134A system uses polyalkylene glycol, or PAG oil, to lubricate the system. The R12 system used mineral oil. Mineral oil loses its viscosity when mixed with R134A, so PAG oils were developed. The tag on the compressor will identify the type of PAG oil specified for the Freightliner system. PAG oils must be kept tightly sealed because they absorb moisture rapidly. Always replace the amount of oil lost during the recovery procedure and compensate for receiver dryer replacement. Before the system is charged, it must be evacuated to remove any water vapor. This is accomplished by lowering the system pressure using a vacuum pump, causing the moisture to vaporize at ambient temperatures. Check the R134A station manual for detailed evacuation instructions. To be certain the system doesn't leak or contain any moisture, connect a thermistor gauge. This gauge measures the vacuum in the system in microns of mercury, compared to inches of mercury as indicated on the charging station's gauges. 1 inch of mercury equals 25,400 microns of mercury. Obviously a much finer and more accurate method of measurement. Evacuate for at least 15 minutes, then shut the vacuum pump down and observe the thermistor. If there is any moisture in the system, the pressure will rise. Continue to evacuate the system. If there's a system leak, the pressure will soar. Repair the leak. Once the thermistor indicates a stable pressure of less than 1,500 microns, the system is ready to be charged with new refrigerant. Before beginning, check the specifications tables for the required refrigerant quantity. After the system has been evacuated, close the low-side valve. Caution, do not open the manifold low-side hand valve or start the engine while liquid charging, or the compressor could be damaged. Program the charging station for the correct weight of R134A required by the system. Use only R134A refrigerant. R12 combines with R134A to form an inefficient gas that results in high pressures and low cooling. If R134A refrigerant is used in an R12 system, it will damage the system. When the system is fully charged, close the manifold high-side hand valve. Run the air conditioner at maximum to check the gauge reading and outlet air temperature. Refer to the specification tables in the service manual for the temperature-pressure specifications. Disconnect the red high-side hose and open both valves on the manifold set. The compressor will draw the refrigerant from the charging station lines. Then disconnect the low side. This completes our look at the Freightliner pre-service checks and service procedures for the R134A air conditioning system. For additional information about the maintenance and service classes and videos available from Freightliner, contact the Service Training Department in Portland, Oregon.